All right, so this is a bit of a part 2 of our soil testing or intro to soil testing webinar, in part just to carry on with the topic of how to sort of look at your soil test results. Didn't quite get to the point in the slides where I thought we might last time. So if you're interested in a little bit more of a sort of planned introduction to some of the numbers you might see on your soil test results, feel free to keep listening and tune into this part 2. So right off the bat, if we're looking at a soil test result from a lab, I did want to just kind of go through what the different numbers on one of the test reports means and provide some examples and context for a few of the different items, and really if you have further questions about what some of the more specific numbers that I don't cover here in detail, something to feel free to reach out through the Kootenai Boundary Farm Advisors or directly to me about what you're looking at. But to start off right off the bat, I think when people think of some of these soil test reports, there's often the idea that it's really just what exactly is in your soil is what you're going to read on the report. And so it's sort of a quantification of all of the things that are there. And unfortunately, just the nature of what's going on down there doesn't really allow for such a simple readout. So it's a lot more complex than just how much of each of these things is present within the soil. And a lot of that has to do with the way the organic and chemical components within the soil interact and what is and isn't available at different times of the year. And then when we're analyzing these things, soil is messy, and it's actually quite challenging to get or to capture a good measure of a lot of the things within the soil. And so over the years, a whole bunch of different approaches have been developed in lab to assess the different forms of nutrients and chemicals within the soil and to try and provide some sort of usable information out of that. So what you end up with is, on the surface, a lot of numbers that look really similar, but some of them really mean different things and have been developed in different ways through the lab process. So at a high level, just wanted to kind of walk through some of these items here. I'll move on. And so if we're essentially, I'll just highlight a couple things in boxes along the soil test and give you a quick idea of what's going on there. And so an organic matter readout on the soil test report is really a quantification. It truly is how much organic matter is present within your soil as a concentration. And that's just something they essentially incinerate the soil and burn off the organic matter, and they can tell the difference of what was there before versus what happens after you burn it off. And so it gives you a sense of how much of your overall soil makeup is made up of organic components. Then phosphorus is probably one of the trickier ones within the soil testing process, in part because a lot of different methods are used to assess it. So it's one to be a little cautious of. And you notice right off the bat on this soil test report, there's actually two soil test phosphorus values. And that's related to how we extract those phosphorus from the soil in order to measure it. And so I'll talk about that one in a little bit more detail because I think it's worth giving folks a heads up on how to interpret that information. But I think one of the big differences between organic matter, or looking at a number like the organic matter and then looking at the phosphorus, is that the phosphorus isn't an exact how much phosphorus is within the soil. It's an extraction that gives you a sense of potential availability of phosphorus. Then one of the other really important numbers on a soil test that you'll look at is the pH. And so this one, it's again measured on its own. It's a measure of sort of the acidity of your soil. So how much how many hydrogen ions essentially are present, resulting in either an acidic or alkaline soil. And so that'll be on a scale of 1 to 14. We'll talk a little bit more about the impact of that, but it's kind of a unique measure compared to a bunch of the other ones, which are flat out concentrations. Then there's a bunch of other nutrients that are around on a soil test report. And depending on where you send your soil samples, they may be extracted in different ways. But here, these, similar to phosphorus, most of these represent an extraction of the soil to give a sense of what a potential availability of these nutrients will be. And depending on how how likely they are to disassociate with soil. It'll be a stronger or a weaker relationship of um, of uh, of the true sort of content of those nutrients within soil. So something like calcium has, there's a lot of calcium within a lot of within the actual just minerals of soils, even non sort of calcareous soils. And it's the challenge is that a lot of calcium is just sort of in mineral particles. It's not something that easily dissolves within solution. And so the number you see here in a soil test is kind of what is likely to become into solution, whereas the true value of calcium within the soil is often much larger. One of the numbers that's kind of a wild card a lot of the time, and that is different from some of the other nutrients that are measured within soil, is nitrate. And so that's the main measure of how much sort of nitrogen is found within the soil. And it's in a way kind of a poor measure of how much nitrogen is within the soil, but it's what we've got. So nitrate, nitrogen, it really is usually a concentration of what's found within the soil at a given time. And I'll talk about why that's a bit of a challenge in a bit more detail. So otherwise, there's other macro micronutrients that are extracted from the soil in a similar process to some of the big ones. And again, they're just items to watch out for, as it's not necessarily the full total value of these within the soil, but more of what you might expect in terms of availability. Most soil labs will do some sort of indication of what's identified here as the CEC, which is the cation exchange capacity. And associated with that usually is some sort of sense of the different cations, so positively charged ions, that are sitting on those exchange sites within the cation exchange capacity. So the initial CEC value is sort of a quick measure of essentially the holding capacity for those positively charged nutrients. And then the base saturations is within that overall holding capacity, how much of it is made up of certain types of nutrients. And so there's a bit of repetition where you have, for instance, potassium that's surrounded by the orange box is a flat out, extraction value of potassium from the soil. And then there's another value again on the base saturation, which is telling you how much of the sort of holding capacity of your soil is taken up by potassium ions. And so some labs will have some information about sort of targets, or they might provide you with a bit of interpretation on, if they find that some of these base saturations are out of whack. But it's a slightly different approach to interpreting soil samples. So it's a lot of technical stuff, and in part the reason for berating you about the different ways things are analyzed within soil samples is, I think, to reinforce some of the big pictures and areas that really I'd encourage you to interpret slightly differently on the piece of paper. And so things that you want to kind of remember or watch out for when you're looking at these things is to think differently about measures of actual concentrations of things versus things that are an extractable concentration. So it's not the total concentration within the soil, it's a concentration that was able to be extracted with certain chemicals. And so to contrast those things, like our organic matter was a total amount within the soil, whereas when we were looking at a nutrient like phosphorus, that's an extractable concentration. And usually it's referred to as soil test phosphorus, not just soil phosphorus. And then otherwise, really want to emphasize that that you differentiate between, say, potential availability of a nutrient that's measured versus what's actually in the soil at the time of sampling. So some of the measures provide, here's what's there now, and then other measures provide, if we use some chemicals to extract some of this nutrient from the soil solution, then what's the sort of potential availability that you might expect from that? And so it's not really what's exactly dissolved in soil water at that given moment. It's sort of a bit of a index of what you might expect a plant to have access to. And so essentially that's a really big contrast between something like phosphorus, which is in that sort of, it's an extracted nutrient and not the flat out just what's contained within soil, like the soil water at the time of sampling. And then something like nitrate, where really most of the nitrate that you see on the test result it's what's just floating around in soil water at the time of sample. Then as you're sort of looking at some of the test reports, have a sense if there's items that are calculated versus measured, or sorry, if they're calculated versus estimated values. And so an idea here would be organic matter, which, as I mentioned, something that the lab will usually measure and fairly straightforward. And so often on labs, you might see something, or on lab reports, you might see something like an estimated nitrogen value. And that's something that the lab, unless you've asked them to perform some sort of add-on nitrogen incubation or extra process, which would be an extra fee, chances are what they're doing is they're just using some of the existing measurements and then a formula of some kind to estimate what they expect from nitrogen release. And so often that might be based on, like the estimated nitrogen value. They probably will base it on something like the organic matter, but just be aware that it's not something that they've likely fully measured. And if you can get a sense of how they're doing that, and if you want to trust that value, because they'll use that to inform some of their crop recommendations. So if we're looking at a few of the specific results, did want to just kind of highlight some of the really big ones and walk through some extra context that will hopefully allow you to interpret that on your own. As I mentioned, one of the really fundamental ones to look at when you're reviewing your soil test report is the soil pH. And it's one of the most influential characteristics of soil in terms of the availability of all of the other nutrients. So if you look at this diagram here, you've got all the different types of essential plant nutrients. And as you move away from sort of the middle ground of soil pH, you start to see real challenges in availability of certain nutrients. And so there's definitely a sweet spot within the middle. And so that tends to be a slightly acidic soil. And within that range, most of the plant nutrients are sort of at their most available. It's not totally uniform, but it's generally just kind of that nice zone to be in. Not all plants are the most happy within this range, and a lot of that has to do with where they've actually developed as a species. But it's just the generic rule. So when you're thinking about pH, there's that, how does it affect nutrient availability? And then also just the crop suitability to different pHs. And this is just a reference from one of the BC production guides to go through. Actually, I believe it's on one of our pH fact sheets, but just highlights the different ranges that our different crops like to exist within soil pH. And so if you start to get really out of whack, where your soil pH is maybe dropping due to, if you've been using prolonged, or if for a long time you've been using something like nitrogen fertilizers, if they're urea based or based in ammonium, it can gradually affect soil pH over time. And so you might have to monitor as you're producing if your pH is changing. And if you start to get out of the zone of sort of happiness for some of these crops, might be something you need to adjust with lime. Or if you're just sort of starting out and trying to figure out what crops might be suitable for your space, have a sense of if you're going to need to make adjustments to soil pH before really digging into something. One of the other nutrients that I mentioned was kind of challenging on soil test reports was that soil nitrate. And so I did want to kind of berate on this one a little bit, just because I think it's of interest for a lot of folks, because it's often the most limiting soil nutrient for plant production. It's one that's used in large quantities as a fertilizer form, and it's an expensive one to deal with if you're using inputs to supplement it. So don't really want to go all the way into the nitrogen cycle, but really just the whole point of putting this out here is to emphasize that soil test measured nitrate, and nitrate is just this little part of that big cycle. And really in the soil, it represents, most of the nitrogen within the soil is actually found in all of the other forms, mostly in the organic forms. So you're measuring this tiny portion of what actually exists within there, and it's a very transient portion. So it's constantly going through, or as long as the conditions are right, it's going through all sorts of different biological reactions that transform it into, whether it's the bodies of microorganisms, plant uptake, and other processes that might shift where the nitrogen actually exists in terms of its chemical form. And nitrate is the sort of most available form for most plants. Some plants are more adapted to take up the ammonium form of nitrate, the other sort of mineral component. But just be aware that when you're looking at that soil test, it's just a portion of what's going on. And so you have to kind of use that within your interpretation and deciding what value to put on that number. And so, I think on the example soil test we saw there, the nitrate value was low. And so I'd really sort of, if you're seeing a rating or an evaluation of a nitrate value, it's always important to sort of think about the context of the soil test report. And so a low result on a test doesn't necessarily mean that your soil will always have low available nitrate. It might just be related to when that sample was taken. And so be aware of, was this taken in like the end of season when you'd expect plants to have taken up most of the nitrate that was floating around within soil that you might have supplemented. And maybe the soil has gone back down to sort of its residual or its level of nitrate that is present when things aren't being supplemented. Because most soils don't have a ton of free nitrate just floating around in their natural state. Usually that's a result of our management to bump up nitrogen availability. The other thing to really keep an eye on if you're interpreting nitrate is the depth of the soil sample and how that relates to timing and potential water, because nitrate's really mobile within soil. If you want to get a sense of the total available nitrate within soil, you probably ought to be looking at deeper soil sampling because it does move downwards through the soil profile with water freely. And then be aware that, there's biological processes that drive that nitrogen cycle. And the rate that nitrate becomes available is dependent on the things that influence all the organisms that are involved. And so essentially, if we have conditions that provide optimal temperature, the good amount of oxygen and moisture to make nitrogen availability kind of go, then you'd expect more nitrate availability. But if you're at a time of year where those things have slowed down, so things start to cool off, maybe there's more and more water or less water, it'll influence how much nitrate might actually be around it. And sometimes those factors will influence things like nitrogen loss. So just be aware that there's an ongoing process here. And so you're really just capturing that snapshot of it at one point in time. So when you're looking at nitrate values, the results will come back in parts per million as a concentration. And when we look at, if you contrast that with some of the other nutrients where they also come back in parts per million concentration from a soil extract, but usually that's just referenced against sort of a sufficiency level, whereas soil nitrate is because it is just a measure of how much was within the soil at that time. Usually what's done is sort of that's quantified out into pounds per acre or kilograms per hectare, and that's just something that's assumed to be available for crop production if the soil sample was taken at the right time. So be cautious of sort of assuming that what was present in the soil when you sampled was going to be, will hang around for when the plants actually need it. So just consider when the soil sample was taken. But it is pretty straightforward. If you see parts per million on your soil test, to convert that, there's that sort of rough rule of thumbs that you can use. If it's a sample from the top of your soils, the 0 to 6 inch region, you can just multiply that by 2 and you'll end up at sort of roughly you'll end up roughly at the pounds per acre. Or if it's a deeper soil sample, which means you're including more of the mass of the soil within and the concentration of nitrate found within more sort of depth, then just multiply by 4. If you want a really accurate and fancy conversion, we do have a tool online that can do that for you, and you can fiddle around with the different depths that your soil samples are from, or if you know information about soil bulk density, you can adjust that to get a real sense of what the actual nitrogen content within your soil is. So one of the other nutrients that can be fun to interpret on a soil test, and one that I think we had talked about when we were going through some of the questions with Rachel in our earlier session, was phosphorus. So we did talk a little bit about that. there's different forms of extractants that are used for soil test phosphorus, and depending on the lab, they may use different extraction processes. This lab, as the example, actually uses 2 different processes, and the difference there being that some of them are suited to more alkaline soils, others are suited to the neutral to acidic range. And so depending on where your soil pH is at, so I believe this one, we've got an example where soil pH is sort of down into that more acidic range. Likely we should be looking at the Bray extraction to interpret that. They both ended up with a medium rating, so I guess not super not a whole lot of differentiation there, but just be aware that there is a bit of a different use for the different extractions. Our ministry does have a tool online. If you've got different types of soil extractions, it is possible to convert, so to be able to compare between the different extraction processes. But and largely that's if you're trying to get things towards what is the BC standard for phosphorus extractions is called the Kelowna extraction. And if you're looking to convert into that measure, you can use one of our online resources for that as well. But I did just kind of what we hinted at earlier when looking at the actual overall report, was that the actual soil test phosphorus that you see there is removed from the soil for measurement, and it's using an extractant solution. And so, as I mentioned, this is a bit of a repeat, but there's different extraction methods. So if you send soil to different labs, they'll use different processes and the numbers will be different. So you should expect that. And if you want to be able to compare between labs, you probably need to be looking at converting the values. But overall, we don't really recommend trying to make that lab to lab comparison, just because it's more than just the extraction process that's different. Labs will have their own just variations on handling processes that overall could result in some differences that makes comparing difficult. So, and again, this is just kind of reiterating that soil test phosphorus isn't really a measure of the overall amount of phosphorus within the soil. And so it's that extractant that actually provides an approximation of what the plants might potentially have access to while they're growing. And so when you're looking at the ratings besides soil test phosphorus, they relate to what the measured level of soil test phosphorus is, and that's sort of compared against how much additional phosphorus might be needed in order to get to sort of optimal plant growth. And what that looks like, and when you're looking at phosphorus or some of the other nutrients, it's sort of this plant sufficiency curve when we talk about soil nutrient inputs. And so if the soil level along the x-axis there is really low, it means that by supplementing with extra nutrients that will be available for the crop, you're going to affect the overall yield. And so adding something will provide positive benefit to your cropping situation. And so as you move to higher concentrations within the soil, to a range where you get close to sufficiency, the more inputs that you add will have less benefit. And so you'll see sort of a declining return on fertilizer, to the point where you get adding more fertilizer will not actually help boost growth of that one specific nutrient. So it's not a sort of linear relationship where the more you add, the better results you get. There's that declining return, and that relates to, if the soil is able to provide enough on its own, and the plant really only requires so much of some of these nutrients. So you'll hit that sufficiency level eventually, and that's usually when on the soil test you'll see its rating being good or high. And if things get really high for certain nutrients, there can actually be harm done if you apply more. And so once you start applying too much of certain nutrients, it can cause damage to the crop itself as a result of just excess or toxicity from that. But more commonly, it's more about sort of interfering with some of the other nutrient uptake. So once you start sort of bumping, if you're supplementing too much of one thing, it can bump the availability of some of the other companion nutrients. And so just be cautious of if you've hit sufficiency on some things, of adding too much more of that. And so again, that sort of sufficiency level is the point where, adding more inputs of that isn't going to actually improve your overall yield. But if you're below that sufficiency level, that's really the point where adding more phosphorus, or if it's a different nutrient, potassium or something else that's being evaluated, adding more of that will sort of move you towards optimal yields. And most labs have a database of research that they use to inform those values, where there's work that's being done to assess at this soil test value, how much phosphorus do we need to add in order to reach that optimal yield response? And so what that might look like is, and it's not really the most complex process, what's going on behind the scenes or underneath your lab report. And this is an example of the sort of soil test interpretation data that the province keeps. And so, there's different crop groups on sort of the vertical axis here, and then the different soil test levels that you see on the left-hand side. And so depending on where your soil test level is at, there's a recommendation for how much of, in this case, potassium is needed in order to reach that optimal yield. And so, if we have a pumpkin crop and our soil test results, or the extraction of potassium is coming in at, say, like 90, then there's a recommendation of how much supplemental potassium is needed to reach our yield goals. And so that's really, in the background, what's going on. It's not super complex. You have a soil test readout number that's referenced against the crop, and it'll look it up on a table like this and spit out what the recommended fertilizer rate is in most cases. Some of the other nutrients might be a little bit more complex, but generally this is a pretty standard approach. And so most of the kind of other nutrient concentrations that you see on the soil test report, so if you're talking about magnesium or calcium, a lot of them are concentrations that are from similar extraction processes, and then a similar evaluation of the concentration was shown as this. This is the recommended amount of fertilization that's needed in order to reach just optimum production. And so kind of went through in a bit of detail on some of the items like phosphorus, but a pretty similar approach is used to assess a bunch of these other nutrients. So, if we're looking at potassium, magnesium, or a lot of the other macro and micronutrients, some of these are done, if a lab is using a malic extraction, it does these all at once. And so it's a similar process. So that gives you a bit of a sense of what's going on behind the scenes, I think, in that one piece of paper. And hopefully the main emphasis being that it isn't just, here's exactly what's in the soil right now, the overall concentration of these things, and run with that. There's, as I mentioned, just the nature of soil is a little bit complex, and trying to measure some of these things is a bit challenging. And so the best processes that we've been able to develop to extract some of these nutrients is what the labs are using, and then as you're interpreting it, it's good to just know what you're looking at and how to make use of that information. So if you do want to kind of play around with soil test reports, our ministry has a couple different online tools that are accessible to you. Some of them are for some of those conversions that I mentioned, but otherwise we do have a broader nutrient management calculator that kind of walks you through a lot of this process of inputting soil test results, getting ratings and evaluations back based on the BC Kelowna extraction values. And then you can fiddle around with some of your yield goals and parameters and get a sense of what the recommended sort of supplemental nutrient applications might be. And then it'll walk you all the way through if you use different approaches to provide nutrients for that, especially if you're using organic amendments like manure, what the sort of impact of that would be on your soil. And so if you're keen, I do recommend having a look at that. And then otherwise, for some of that basic information around just how to take a soil sample, there's sampling guidelines on the website, as well as a list of places that you can send soil samples for analysis. So please feel free to reach out. There's my contact information there as well. And We do have within the ministry, I'm just sort of regionally based, but we do have within the ministry soil and nutrient management specialists as well that can support sort of some of our more complex questions. So can provide connection to those individuals as well. All right, well, thanks so much. Hopefully, if you made it this far into part 2, hopefully you enjoyed some of the content.